Oh, we started. Sorry. Now, here's what we're going to do. We are going to go to this ESPN home run tracker, and I'm going to go to the main page, and we're going to see how the effects of air resistance and everything else. Let's look for one of our Royals here. Let's go for the full listing. Oh wait, let's do hitter team. Let's go to the Royals. Are any Royals hit a home run recently? I think these are the furthest home runs. 495 feet. That's amazing. That's amazing. So let's just watch this and see. I would like to see the Royals, but okay. So here's Stanton's monster hit.
Stanton drills it deep left field like a rocket. Up into the seats it goes. That's 20 rows up in the deepest part of the park, and Stanton has untied this game. Wow. He hits them here. When he hits them here, man, they just go and go and go.
Colorado Rockies.
It was amazing watching the whole defense for the Rockies just freeze. Nobody moved.
That's what 504 feet looks like.
It's actually 490, but that's about as far as you could possibly hit a baseball. Okay, that's about as far as you can possibly hit a baseball. So let's take a look at this one. And here's the deal. Let's take a look at what the actual that was the farthest one. Where was that? 490 feet. Oh, 486 standard distance. 480. Yeah, this was it in Colorado, the Rockies. All right. And okay, so we're going to go with that one. And look, true distance was 495. All right, 495 feet. Speed off the bat was 120 miles an hour, so we'll have to convert that to meters per second. The elevation angle was 22.7 degrees. Okay, so let's figure out if he hit a ball at 120 miles an hour at 22.7 degrees, let's figure out what, and the apex was 84 feet, was the highest it went. I guess that's what that means. Or is that in meters? I know this is in miles per hour. Speed off the bat is miles per hour, and angle is 22.7. So let's figure out what the schoolhouse answer is. In the real world, it went 495 feet. And according to the schoolhouse, let's see how far it went, just for giggles. Okay? All right, so here we go. Let's go here. All right, so so according to this thing, he hit the ball, V naught was 119.8 miles per hour, which we multiply by our 0.447 conversion factor, and we do this in physics and sport all the time. So it's 53.5 meters per second. Whoa, that's a rocket. At an angle, 22.7. Okay, 22.7 degrees. So let's figure out the range. All right. We can't do anything in the x, so we'll look to find the time. So we need the total time. So y, in the y-axis, we've got v naught y is equal to 53.5 times the sine of 22.7. So 53.5 sine 22.7 gives me 20.6 meters per second. That's not much because it's a small angle. Most of it v naught x, which would be the cosine, or 53.5 times the cosine of 22.7 is 49.4. See, most of it's in the y direction. All right. And so, all right, at its maximum height, schoolhouse answer, maximum height says Vy max is equal to 0. So I've got 0 equals 20.6 minus GT to find the T max. So at the maximum height, and then we'll just double that and multiply it by this and get our schoolhouse answer for how far it went. So we got 20.6 divided by 9.8. They all become, everything becomes positive. So because I moved this over here, so 20.6, whoops, 20.6 divided by 9.8. Gives me 2.1 seconds it was in the air, to the maximum height. That's to the maximum height, equals the time it took to get to the maximum height. So the total time is equal to 4.2 seconds. It was in the air. All right, so then the range should be, this is Stanton's homer. Then the range of that thing should be 49.4, our schoolhouse answer, barring air resistance and all kinds of drag and spin and everything else. So I got to multiply that by 2. There's my total time times 49.4. What the hell? Oh, yeah. Scared me at first. 207 meters. That's why I was like, wait a minute, this isn't right. Yes, it is. How many feet is 270 meters? Be honest, I forgot. Meters to feet. So there we go. If I put, oh yeah, it's 3.28. So if I put in 207 meters, 679 feet. That's the schoolhouse answer. I don't think I'd want to give those coordinates. I don't think I'd want to be the aerial observer for this simple of way of looking at how projectiles actually move. You're gonna shoot a lot of rounds too far, or you're gonna drop them way too short. All right. Anyway, so I just thought that'd be kind of a fun little exercise to do. All right, out here. That's it. That's it for this lesson for Tuesday. I know it's a lot, but it's actually, well, this goes into Thursday too, because the only thing we got left from this chapter for Thursday is relative velocity.